Welcome! In this video, we'll explore what particulate matter is, what are the sources, how it's measured, and its impact on our health and the environment. We'll also discuss solutions to reduce PM exposure and improve air quality. Let's dive in. Particulate matter, or PM, is made up of microscopic solid and liquid particles suspended in the air. These particles can come from both natural sources, like wildfires and volcanoes, as well as human-made sources, such as vehicle emissions and industrial activities. PM has a significant impact on our health, air quality, and even contributes to climate change. For comparison, human hair is about 50 to 70 micrometers wide, making these tiny particles even harder to see, but still potentially harmful. Particulate matter, PM, is a significant air pollutant that contributes to respiratory diseases. Fine particles, like PM2.5, are so small that they can enter the bloodstream, causing severe health issues such as heart disease, lung cancer, and asthma. In addition to health impacts, PM can also reduce visibility, contributing to smog formation. Furthermore, it can transport toxic chemicals across long distances, spreading pollution far beyond its origin. Particulate matter is classified based on size, and each classification has different sources and impacts. Visual, particulate sizes with corresponding labels. Narrator, or on-screen text. PM10 includes particles that are less than or equal to 10 micrometers in size, like dust, pollen, mold, and smoke. These particles are larger and can be filtered by the nose and throat. PM2.5 refers to even smaller particles, less than or equal to 2.5 micrometers, coming from sources like combustion, organic compounds, and heavy metals. These fine particles can penetrate deeper into the respiratory system. Ultrafine PM consists of particles smaller than zero point 0.1 micrometers, typically from vehicle emissions and industrial processes. These particles are so small they can enter the bloodstream. Lastly, nanoparticles are extremely tiny, less than 100 nanometers, and are found in modern materials and advanced industries. These particles can have significant environmental and health impacts. Particulate matter, PM, comes from both natural and human-made sources. Let's explore some of the key natural sources. Volcanic eruptions release ash and sulfur dioxide, contributing to the presence of larger particles in the air. Forest fires emit carbon soot and organic compounds, creating fine particles that can travel long distances. Dust storms, often caused by soil erosion from wind and droughts, spread coarse particles through the atmosphere. Sea spray from ocean waves releases salt particles into the air, which can affect coastal air quality. Biological sources, such as pollen, fungal spores, bacteria, and viruses, are another natural contributor to particulate matter in the air. In addition to natural sources, many human activities contribute to the formation of particulate matter. These are known as anthropogenic sources. Industrial processes, such as steel mills, power plants, and refineries, emit metal and chemical-laden particulate matter, contributing to air pollution. Transportation is another significant source, with diesel and gasoline vehicles releasing PM 2.5 and ultrafine particles, which have a serious impact on air quality and health. Construction and demolition activities release dust from materials like cement and silica, along with other particulates that pollute the air. Agricultural activities, including the use of fertilizers, pesticides, and soil disturbance, generate particulate matter, especially during planting and harvesting seasons. Finally, the burning of fossil fuels, such as coal, wood, and biomass, releases significant amounts of particulate matter, contributing to air pollution and global warming. Dust storms, often caused by soil erosion from wind and droughts, spread coarse particles through the atmosphere. Sea spray from ocean waves releases salt particles into the air, which can affect coastal air quality. Biological sources such as pollen, fungal spores, bacteria, and viruses are another natural contributor to particulate matter in the air. Particulate matter, PM, is made up of a variety of chemical components, and understanding these is key to understanding its environmental and health impacts. PM includes metals like lead, arsenic, cadmium, nickel, and chromium, all of which can be harmful to human health. Organic compounds such as polycyclic aromatic hydrocarbons and dioxins are also found in PM, often originating from combustion processes. Inorganic ions like sulfates, nitrates, and ammonium contribute to the particulate load, affecting air quality and climate. A significant portion of PM is carbon-based material, including soot, black carbon, and organic carbon, which come from sources like vehicle emissions and industrial activities. Biological content in PM includes viruses, bacteria, and allergens like pollen, which can impact human health, particularly for those with respiratory conditions. As shown in the chart, different sources contribute to the makeup of particulate matter. This chart highlights the contribution of dust from sources like soil, urban areas, construction sites, and power plants, along with emissions from motor vehicles and steel production. Exposure to particulate matter can have significant health effects, both in the short and long term. In the short term, PM can cause eye irritation, coughing, wheezing, and shortness of breath. These symptoms are common when air quality is poor, particularly during high levels of pollution. For individuals with existing respiratory conditions, PM exposure can worsen asthma, chronic obstructive pulmonary disease, and increase the risk of lung infections. PM doesn't just affect the lungs. Long-term exposure can also lead to cardiovascular diseases, increasing the risk of heart attacks, hypertension, and stroke. Neurologically, fine particles in the air have been linked to cognitive decline and neurodegenerative diseases, including Alzheimer's. Finally, fine PM, especially those containing polycyclic aromatic hydrocarbons and metals, poses a significant cancer risk, particularly increasing the likelihood of lung cancer. PM2.5 particles are so small that they can penetrate deep into the lungs and enter the bloodstream. These fine particles are among the most harmful to respiratory health. Exposure to PM2.5 can aggravate asthma, bronchitis, and lung infections, making it harder for individuals to breathe and recover from respiratory illnesses. Additionally, PM2.5 reduces lung function, which is particularly concerning for children and elderly populations who may already have weakened respiratory systems. These fine particles also carry toxic chemicals that can cause inflammation and tissue damage in the lungs, leading to long-term health problems. PM doesn't just affect the lungs. Long-term exposure can also lead to cardiovascular diseases, increasing the risk of heart attacks, hypertension, and stroke. Neurologically, fine particles in the air have been linked to cognitive decline and neurodegenerative diseases, including Alzheimer's. Finally, fine PM, especially those containing polycyclic aromatic hydrocarbons and metals, poses a significant cancer risk, particularly increasing the likelihood of lung cancer. Exposure to particulate matter, PM, is not only harmful to the respiratory system, but it also has serious effects on cardiovascular health. PM exposure is linked to heart attacks, strokes, and arrhythmias, or irregular heartbeats. This is due to the inflammatory response and oxidative stress caused by fine particles entering the body. It also leads to inflammation and damage in the blood vessels, contributing to the development of heart disease. Chronic exposure to PM increases the risk of hypertension, high blood pressure, and atherosclerosis, hardening of the arteries, both of which are major risk factors for cardiovascular disease. Moreover, individuals with pre-existing heart conditions experience higher mortality rates due to the harmful effects of PM on their heart and blood vessels. Particulate matter, PM, has a profound impact on the environment, not just on human health. First, PM can reduce visibility. As particles scatter and absorb light, they create haze and smog, making it difficult to see clearly and affecting our ability to enjoy natural landscapes. PM also contributes to climate change. Black carbon, a type of particulate matter, absorbs sunlight, warming the atmosphere and contributing to global warming. Additionally, sulfates and nitrates found in PM can cause acid rain. This acid deposition harms water bodies, soil quality, and ecosystems, impacting both natural and agricultural systems. Lastly, PM can cause significant damage to ecosystems. It contaminates soil, water, and plants, disrupting growth and the overall health of ecosystems. Thank you for watching. Stay informed, and let's continue working towards cleaner air and a healthier environment. To understand the concentration and impact of particulate matter, PM, in the air, various monitoring techniques and tools are used. One common method is gravimetric analysis, where air filters capture PM, which is then weighed to determine the concentration of particles in the air. Optical particle counters are also widely used. These devices measure particle size and number in real time, providing immediate data on air quality. Beta attenuation monitors use beta ray absorption to measure PM levels, offering continuous, accurate data for environmental monitoring. Finally, aerosol spectrometers help determine the particle composition and distribution of PM, allowing scientists to analyze the types of particles present in the air. Finally, PM contamination damages ecosystems. It affects soil, water, and plant growth, disrupting habitats and food chains. Chronic exposure to PM increases the risk of hypertension, high blood pressure, and atherosclerosis, hardening of the arteries, both of which are major risk factors for cardiovascular disease. Moreover, individuals with pre-existing heart conditions experience higher mortality rates due to the harmful effects of PM on their heart and blood vessels. To control and reduce particulate matter emissions, several advanced technologies are used to capture and remove PM from industrial processes. Electrostatic precipitators, ESPs, use electric charges to remove PM from industrial emissions. These systems work by charging particles and using electric fields to capture them. Baghouse filters, made from fabric, trap PM before it is released into the atmosphere. These filters are highly effective at capturing both fine and coarse particles. Wet scrubbers are another technology that uses water or chemicals to capture PM and gaseous pollutants. They spray these substances to remove contaminants from the air streams. Finally, cyclone separators use centrifugal force to separate larger PM particles from air streams. This technology is often used as a first line of defense for larger particles before finer filtration methods are employed. Reducing particulate matter in the air requires effective regulatory measures at both the governmental and community levels. One key measure is setting emission standards. Governments must establish limits on PM emissions from both industrial processes and vehicles, reducing the amount of harmful particles released into the air. Air quality monitoring networks play a crucial role in tracking PM concentrations continuously. These systems provide real-time data that helps inform policy decisions and public health guidelines. Transitioning to clean energy is another essential step. Reducing our reliance on coal and diesel will help decrease PM emissions and lead to cleaner, healthier air. Urban planning also has an important role to play. By creating low-emission zones and green belts, cities can minimize exposure to harmful PM and create healthier environments for residents. Reducing particulate matter, PM, requires not just technological innovations, but also significant public and policy actions. One important step is encouraging public transport, cycling, and walking. This reduces the reliance on private vehicles, which are a major source of PM emissions. Another key measure is phasing out high-emission vehicles, particularly diesel-powered cars and trucks, which release large amounts of particulate pollution. Reducing agricultural burning is also essential, as it releases large amounts of PM into the atmosphere during practices like crop residue burning. Implementing green infrastructure, such as urban tree plantations and green belts, can help absorb PM, improve air quality, and reduce urban heat islands. Lastly, raising public awareness about air pollution and its health risks is crucial for building support for these initiatives and encouraging individual action. As we look toward the future, several key areas of research are poised to make a significant impact in controlling particulate matter and improving air quality. Advanced air purification technologies are being developed to create more efficient filters, including innovative nanotechnology solutions that can capture finer particles from the air more effectively. Emission-free transportation is another focus. The adoption of electric and hydrogen-powered vehicles will be critical in reducing PM emissions from the transportation sector, one of the largest contributors to air pollution. Stronger international agreements are necessary to address transboundary air pollution. Cooperation between nations is essential for tackling the global nature of PM pollution and ensuring cleaner air for all. Finally, health impact studies are ongoing, with a focus on understanding the long-term exposure effects of PM. More research will help to uncover the full scope of health risks and guide future protective measures. Particulate matter has a significant impact on air quality, public health, and our climate. As we've seen, addressing PM pollution requires a multifaceted approach that combines scientific research, technological innovations, and strong policy measures. Together, we can develop effective solutions to reduce PM emissions and improve the quality of life for people around the world. The work is ongoing, and each of us has a role to play in this global effort. Thank you for watching. Stay informed, and let's continue working towards cleaner air and a healthier environment.